Welcome back to your learning journey. Now, in this video, we are going to learn and understand about one of the most commonly used term in machine learning domain, that is MLOps. Now, MLOps actually means that it actually stands for the machine learning and operations. So as we proceed in this video, we will understand what exactly is this MLOps, the various use cases of MLOps, and the reason that we would require this MLOps, the key benefits that we would get, and at the end of this video, I'll also give you a quick walkthrough on the AWS SageMaker Studio. So that's the agenda of this video. So let's get started. Now, if you're new to our channel, please consider subscribing and feel free to connect with me on LinkedIn. So I look forward to meeting you and let me know your feedback. Okay, so let's get started and let's understand what exactly is this MLOps? So MLOps actually stands for the machine learning operations. I can say this MLOps as a core function of machine learning engineering, and this is basically focused on streamlining the entire process of taking the machine learning models to the production and not just deploying it to the production, but along with that, we are interested in maintaining as well as monitoring those machine learning models. Now, I can say this MLOps as a collaborative function. Now, in the case of MLOps, so this MLOps team will basically consist of the data scientist, DevOps engineer, as well as the IT practitioners. So this is the core idea about this MLOps. So in this case, we want to ensure that whatever the machine learning models that we are trying to build and deploy, it follows the right strategy so that as a business, they would get the maximum benefit. Now, the reason that we want to use this MLOps approach because here this is actually focused on creation as well as building the quality machine learning models. And by adapting this MLOps approach, the data scientists, the machine learning engineers, they can actually collaborate and increase the pace of model development and the production. Now we'll be able to achieve this by implementing the CI/CD practices, that is the continuous integration and the continuous deployment practices with the effective monitoring, validation, and without forgetting the governance of the machine learning models. So with this approach, this would enable the business and the IT teams to bring the models to the production system with as as minimum time as possible. So that is the overall idea of this MLOps. Now, the reason that we want to focus on this MLOps because I'm sure if you have worked in any machine learning project, so like most of the machine learning activities that we'll be doing in our localized environment like the Jupyter Notebook or the Google Colab instance. So it will all be comprised of the experiments that we'll be running on the machine learning algorithms and the data set that we are working. Now, when we talk about productionalizing that specific model, which I have experimented, which is one of the, I would say, one of the 100 experiments that I've ran, then think about the complexities that is involved. So here, if I talk about a machine learning project, first thing is it is an experiment based approach. Where as a data scientist, you would experiment with various approaches on the data set, apply the pre-processing, and then apply the relevant machine learning model, perform the hyperparameter tuning, and then you have to do the deployment. So there are a lot of things comes into picture. So if I talk about from the production perspective, so first thing, obviously, you'll have a data engineering part where the data ingestion will takes place by getting the data from various sources. Then as a data scientist, you will prepare the data set which is ready for training, which is where you will start applying the pre-processing techniques on the data set, format the data, fix the data errors, and then perform the model training, followed by hyperparameter tuning of the model, then model deployment, and not just that, model monitoring, whether the model is working as per the expectation or not. And at the end, you also have to ensure you have the explainability present, because explainability is an important element in the machine learning models. So these are the various components that we will have whenever we are working on a machine learning project. And not just that, as you can clearly observe in the case of machine learning deployment, it has got the collaboration and it has got the handoff to happen between the teams, like it could be the data engineering team, data science team, and also the infrastructure team. So I can say that in case of machine learning deployment, it requires the stringent operational rigor in order to keep all the processes synchronous and working as per the expectation. And this MLOps comprises the experimentation, iteration, continuous improvement of the machine learning lifecycle. So that is the key benefit of using this MLOps, which is also known as the machine learning operations. So the key benefit of using this MLOps approach obviously is the increasing of the efficiency and the scalability and reducing the risk whenever you are deploying the machine learning models to the production. So when I say efficiency, it would allow the MLOps and the data science team to achieve faster model development, and it would help them to deliver the high quality machine learning models, faster deployment and the production. And scalability means here the MLOps enable the vast scalability and the management. So here it would help us to manage the model versions in a better way. And out of all the thousands of experiments that we'll be running, we can identify which is the specific model that I want to use and what are the metadata related to that model, like the pre-processing techniques that I have applied over there in that machine learning pipeline. Some of the like some of the small things that we have specified about the model configuration, which might have missed it whenever we are doing it manually. So it will help us to track the machine learning model versions and help us to scale it to the very big data set using the cloud infrastructure. And specifically, this MLOps provides the reproducibility of the machine learning pipeline. So as a result of this would enable a tightly coupled collaboration across the data teams. This would reduce the conflict. And here, majorly, what we would observe is at least the challenge that we had faced at the initial period of machine learning deployment was, so we were getting some conflicts between DevOps and the IT with the data scientist team. So by using this MLOps approach, we will be able to reduce the conflict. And as a result of this, we'll be able to bring the models to the production in a much faster pace by reducing the risk. So here in case of MLOps approach, not only we talk about deploying the models, but also monitoring as well as improving the governance of the machine learning models. So with this MLOps approach, we can ensure that the models that we are deploying are efficient, they can be scalable, reproducible, and it will help us in reducing the risk. Now, when we talk about this MLOps, so MLOps in machine learning can be focused depending on the project that we are working. Now, in majority of cases, I can say MLOps can consist of the entire thing which are present in the data pipeline to the model production. Now, to give you an example, so here, if I'm working on an end-to-end project, so some of the key items where or the key components that I'll have in the MLOps approach would include EDA, that is exploratory data analysis, data prep and feature engineering, model training and tuning, model review and governance, inference and serving, model monitoring, and the automated model retraining. So these are the commonly used components in the machine learning operations. So using all these components, we will be able to ensure that the models that we are deploying to the production environment is scalable and it is efficient, and we know the risk whenever we are deploying it. So that would enable us to reduce the risk whenever we are deploying the models to the production. Okay, so when we start working with the MLOps, some of the key best practices for MLOps would include EDA, obviously. So at this step, so you will explore the data, share the data, prepare the data for your machine learning lifecycle. So you will ensure that you'll be able to create a reproducible, editable, and shareable data set. Generally, we call it as a data which we will begin with, or which we begin to start analyzing the data. Okay, that's the exploratory data analysis. And this is followed by data preparation and feature engineering. So at this step, we will iteratively transform, aggregate, we will remove the duplicates, and we will ensure that the features that we are working with, it contains only the important features which are relevant for the machine learning model. And then here, at this point of data preparation and feature engineering, we want to leverage what we call it as a feature store, which is like a centralized repository which can be used by various cross-functional teams, which would enable the usage of the same data by reducing the pre-processing work over there. And this is followed by model training and tuning. So at this step, so usage of popular libraries like scikit-learn or hyperopt, tensorflow, pytorch. So we can make use of various libraries to perform the training, or we can make use of like the functionalities like AutoML, which will help me to automatically perform the training on a given data set, and it will help me to create a reviewable and a deployable code. And the next one is model review and governance. So at this point of time, so we will be majorly interested in tracking the model lineage, the versions of the model, how to manage the model artifacts, and the transitions through the various life cycles. So that is what we'll be interested in the component of model review and the governance. And model inference and serving. So here we will be majorly interested in managing the frequency of model refresh. See, once the model is deployed into the production, we'll not just end there. We'll have to monitor the model, how it is working, whether it is deviating from the expected process or expected accuracy. We'll have to manage the frequency of model refresh. So all those things will be taken care in the step of model inference and serving. And then lastly, we've got model deployment and monitoring. So here we will automate the permission and the cluster creation whenever we want to productionalize the registered models, and automatic model retraining. So we'll create a model retrain pipeline where using this we'll create the alerts, and we'll also create an automation to take a corrective action in a case of model drift due to the differences in the training and the inference data. So these are the core components that we would generally have whenever we are working with MLOps on a real-time projects. Now, as I mentioned, if I'm trying to implement this MLOps strategy in my machine learning projects in my production system, obviously we'll be looking at the platform which has got all these capabilities. Now, each and every cloud computing vendor has provided the various machine learning operations capabilities provided with them. And one such service that I'm going to show you today is the AWS. So in AWS, we've got a service that's called as the SageMaker. So SageMaker is a service that we have got in AWS, which will help us to implement the MLOps in an easier manner. So if I want to take you to the page of this AWS SageMaker, this is the AWS SageMaker page in AWS. So we just from the console, just search for Amazon SageMaker. So you'll be able to start this Amazon SageMaker service. So this is the homepage of this Amazon SageMaker service, and I've already created a domain for my individual user. Okay, so I just want to show you some of the capabilities that are present in this Amazon SageMaker, which will help us to implement the MLOps in the machine learning projects in a quicker and a faster way. So on the left hand side, you can see we've got the SageMaker dashboard, images, lifecycle configuration, and so on. So through these settings, we can actually configure how does the overall SageMaker service should work for us. Now, one main thing or the feature that we have got is the SageMaker Studio. So if we launch a SageMaker Studio, so this is how the SageMaker Studio would look like. Now in the SageMaker Studio, we've got various features. We've got Data Wrangler, which is a visual tool that is available to us, where using this we can actually perform the machine learning data processing, and we can actually do it in a visual way. So that's the benefit of this Data Wrangler. And once we prepare the data, we can store those features in a feature store. And that feature store is also an service which is like a feature, an additional functionality provided inside this SageMaker itself. Now I can have the feature store present in the glue, or I can also have it in the S3. I can decide where it has to be stored. And then we have the ability to create the compute clusters, which will help me for performing any batch related work. And we have the AutoML for performing the automatic model training and create a deployable and reproducible code. And under the experiment, we can actually create the experiments that we have run, like a hyperparameter job. We can actually perform those experiments we can track those experiments under the experiments tab. And not just that, in the SageMaker, on the left hand side, if you expand the training, you'll be able to look into the training jobs. So you can look into the status of the training jobs, whether it was successful or not. And if you open that model, you'll get the complete information of the model that you have trained. Okay, so we have that automation over here, and we can create it as a pipeline. And once the model is actually trained, we can go ahead and create the endpoint. So whatever the trained model that I've got, let's take up a scenario like these are the training jobs that I've got. So from this training job, I can click on action and I can say create models. So this is going to create a model for me. And this model is actually a file with that specific setting, which will help me to reproduce the same exact outcome that I have got during the training. Now, using that model, I can then go ahead and create it as an endpoint. So under the inference, so we can save the model, all the saved model will come over here, and we can expose it as an endpoint so that the other services that I've got in my organization can call this endpoint and get the prediction or the inference from the model that we have trained. So using this MLOps tool, so we will not be just limited to our notebook, but from the notebook, we'll be able to reach the production system. So the important components of the MLOps would include, obviously, as you can clearly see, data wrangling, an efficient way to export the data and perform the feature engineering, and store the data in a centralized place like a feature store, and separate the training as well as the tuning or the transform into the various compute clusters using the cloud computing. Automate your machine learning with the help of the features like AutoML. Track your experiments with the experiments feature, and understand the model lineage. And not just that, you can configure a pipeline. It could be a retrain pipeline, or it can be setting up any alerts. We can configure it over here, and finally deploy to a server. So this is about the MLOps and how do we implement this MLOps in an organization. So I hope you enjoyed in this video. So if you have got any questions, do let me know in the comment section. So I look forward to seeing you next time.